Today I would like to look at like terms. This has to do with terms that have the same variables in them, and we can add them, subtract them, and that sort of thing. But first I would like to talk about something called coefficients. Notice the 6x squared. That 6 that's sitting out in front of x squared is what's known as the coefficient. In this case, it tells us that we have 6x squared. So let's look at a couple more examples. Here's an important one here, 1x. Now, we don't have to really put that 1 out there by convention. We just say x or y or whatever. But always remember there's a 1 there, and I'll show you later in the lesson why not to forget that. Okay, we could have coefficients that are fractions. And here one of the Bernoulli brothers is lifting the coefficients up so we can see them better. So we can also have decimals. So 0.4 is a coefficient. So he's lifting a 0.4 up there. And we'll see how these fit in here in our coming problems here. Now, here we have a table. And we have 2 columns. And what we're going to do is we're going to match them up so that we have like terms. So if we scramble around, let's see which ones go together. Notice the 5xy there, our first one on the left hand side. It matches up with 10xy. They both have xy in them. The 2x and the 4x, they both have x in them. The 2x squared and the 5x squared y, they both have an x squared and a y, and so on. They have the same variables. Now, if the variables in your terms are not alike, if let's say one term has an x and the other one has a y, and they don't each have an x and y in them, we can't combine it. We can't add or subtract them, that sort of thing. It's like looking at apples and oranges. Let's say we have 3 apples and we have 2 oranges. We can only say that there's 2 oranges and 3 apples. We can't add them all together. In this case, we have 2 terms. Each has an x and a y in it, so we can combine them. In this case, subtract. What we do is we just subtract the coefficients. Remember, I just talked about coefficients. And that's going to be, we have 3xy. This one here, they both have an a and a b squared. So we can combine them. We're going to add them. So we add the coefficients, the 7 and the 4 together, and we can say that there's 11 ab squareds. I hope you're catching on to the pattern here. Now here's one with decimals. Both have x and y in them. If one would have had, let's say, a z, you couldn't have combined them, but they have the same variables. So in this case, we're going to add the decimals together, and we'll get 0.9xy as our answer. Let's see what surprises we have next. Now here's where, remember the 1x? Well, that is 1b cubed there as the first term. You need to be aware of that because we can add these 2 terms together, and we want to add the 1 and the 99 together, so we get 100 and 100bc cubed. So that's important. Here we have an x squared in both terms. Now we have fractions this time. Now 1/2 is just 2/4. If you reduce it down, it becomes 1/2. So we can add 2/4 with 1/4. Remember, the denominator's got to be the same to add. So we get 3/4 x squared. Now our last problem here, we have both an x cubed and an ab in both terms, so we can subtract the 16 from the 35, which is 19, and so we're going to get 19 x cubed ab as our answer. Thank you.